Now I'd like to introduce the next speaker of the session, Dr. Pilar Guerrieri, who's been living between Milan, London and Delhi for the past 10 years. She holds a PhD with honors from Politecnico di Milano in collaboration with the Indian National Trust for Art and Cultural Heritage in Delhi and Westminster University in London. Dr. Pilar has been extensively studying the city of Delhi, in particular the impact of different cultures on its urban planning and architecture. She has been researching European and Indian culture, the development of megacities, and the effect of cultural exchanges. She developed comparative studies between the urban settlements and different types of architecture and explored the meaning of terms such as tradition, legacies, and heritage. Dr. Pilar, since completion of her PhD, is currently involved in academics as Associate Professor in Delhi at the Italian-Indian G.D. Goenka University and now Adjunct Professor at Politecnico di Milano in Milan. Her courses focuses on cross-cultural studies in the field of urban planning and architecture. She is teaching at the undergraduate and graduate level, being part of the PhD program. Moreover, Dr. Pilar is also part of Ambedkar University as a fellow researcher on the Urban Habitation Research and Documentation Project, and she has been nominated International Advisory Council member of the Indian Trust for Rural Heritage and Development, which is specifically responsible for the development of villages in India. She has been published in several international journals, participated at national and international conferences, and published 2 books on the city of Delhi. Now, let us proceed to Dr. Pilar's presentation.
I am Pilar Guerrieri. I am an historian of architecture, currently teaching at Politecnico di Milano. I teach history, focusing on cultural exchanges, the impact that different cultures and models have on other places and architecture. Mimetic dynamics is an aspect of history of architecture that I am particularly interested in. I have been living for almost 10 years between Italy, UK and India before COVID struck. I have been doing my PhD on Delhi with Professor A.J. Krishna Menon, which was, at that time, it was the head of Intact Delhi chapter. Before starting to teach at Politecnico di Milano, I have been teaching History of Architecture and Urban Planning at G.D. Goenka University in Delhi, and I'm still fellow researcher at Ambedkar University in Delhi. I am the author of Maps of Delhi, published by Neogi in 2008, and Negotiating Cultures, Delhi's Architecture and Planning from 1912 to 1962, by Oxford University Press in 2019. Both results of my PhD thesis. I want to thank SRM School of Architecture and Urban Design for organizing this interesting international virtual conference on built environment science and technology, ICOMBEST 2021. An interesting opportunity to reconnect after a tough year of isolation and an opportunity of sharing knowledge. I'm going to participate on the main theme, architecture and allied domains, sub-theme, history and theories of architecture, and I'm going to focus on a particular new trend of contemporary architecture, human mimicking nature. Human mimicking nature, trends in contemporary architecture, is actually the title of my short intervention. Nowadays, nature is at the center of debate due to dramatic contemporary challenges such as climate change, deforestation, desertification, unbreathable air in cities, seawater pollution, and others. The issue of sustainability and respect for nature is uprising. Architects are more and more, compared to 20 years ago, forced to think sustainable in terms of material, carbon footprint, solar-powered system, use of greenery in their design, and so on. It is important to acknowledge that there are countries like Nordic European ones, Sweden, Norway, Denmark, Finland, that have always been keeping nature at the forefront. being pioneer in this matter. Think, for example, of the work of the Finnish architect Alvaralto and the project that you can see here, Villa Marea, where he directly puts the forest inside the design, or of the contemporary renowned Danish Bacharge Ingalls Group, BIG, who design always with particular care to sustainability and nature. The need for respecting nature has brought an increasing observation of it and a much more careful and deeper analysis of its structures and principles. In different ways, nature and its character have always been a design inspiration for architects, designers and urban planners, at times in a much more ornamental way. Think, for example, at the Western styles such as Baroque, as you can see here, or Art Nouveau, in where nature is an inspiration but is used as a decoration. Or other times, nature has become an inspiration in a much more structural way. See, for example, the use of natural organism structures in the Japanese metabolist movement projects. In this case, we can see Kenzo Tange Broadcasting Center that is inspired by the tree trunk and its branches. As often happened in history, architects and engineers got inspired by nature, sometimes in a much more direct and visible manner, and other times in a much more indirect and subtle way. Copying nature, its structures and processes, altering its scales at times, is still a very contemporary trend. Today, the field of biomimicry is constantly expanding, especially in the architectural realm, becoming a way of humanizing the digital shift by which we are overwhelmed. Biomimicry is a science studying biology and technology that studies the characteristic of living beings as a reference model. Biomimicry emulates model, system, and elements of nature for the purpose of solving complex problems. Biomimetics has given rise to new technologies inspired by biological solutions at macro and nanoscale. The study and imitation of nature has been made possible in recent years by recent technological developments such as programming and coding languages, modeling and 3D printing. These advanced technologies allow to faithfully reproduce the functioning and cellular structure of organisms. Today, one of the main gurus of biomimicry is the American Janine Benyus, founder of Biomimicry 3.8 Institute and the Institute for Computational Design and Construction at the University of Stuttgart. These two are probably the most advanced in the world in terms of research and experimentation in the field. This research aims to briefly explore the contemporary trend of mimicking nature in architecture, highlighting its ancient roots and incredible potential. Perhaps one of the earliest and most famous examples of biomimicry is evident in the history of human flight. Leonardo da Vinci is largely recognized as one of the main investigators of its development, as it made the first studies of real birds and human flight in the 1580s. His original design, called the ornithopter, which was never realized, was showing how man could potentially fly by imitating birds. Many other designers and engineers were inspired by birds in later years. For example, Otto Lilienthal completed more than 2,500 Glinder flights, but it was not until 1903 that the Wright brothers flew the first powered machine in controlled and sustainable flight. These researchers went on to define 20th century aviation achievements and technologies seen today in our skies. Architects have discovered and used nature as a source of inspiration for design. One of the earliest experiments in biomimicry dates back to 1851, when the botanist Joseph Paxton designed Crystal Palace, replicating cellular ribs in the geometric design of the structure of his building. Even the Eiffel Tower is an example of copying something that exists in nature. The French architect Stéphane Sauvestre carefully studied the human anatomy, and in particular the structure of our leg, in order to design the steel tower. Frank Lloyd Wright was a forerunner of what is known as organic architecture, which is not a zoomorphic architecture, but an architecture that interacts directly with nature, emerged from context-genus loci, adopts local material, adapts itself to native landscape. Bruno Taut, Glass Pavilion, for the Werkbund exhibition in Cologne in 1914, also interlays clear association with organic forms, such as natural crystals. In the field of urban planning, there we also have innumerable examples of cities inspired by the animal world. Urban structure designed, for example, as linear beehives. The microcosm of insects is also a rich source for biomimetic inspiration. For example, the sociality of ants inspired the software engineer Marco Dorigo of Brussels University to create mathematical models called ant colony optimization to solve traffic optimization problems. Biomimicry seeks solutions to reduce energy consumption. For example, architect Mike Pierce, that you can see in the image, built an Eastgate building in Zimbabwe in Africa, using termite mounds as a model. A building equipped with ventilation system capable of keeping the internal temperature constant at 31 degrees without the use of power air conditioning, in a place where temperature normally fluctuates between 3 and 42 degrees. Pierce has achieved energy saving of 90%. The inspiration came from observing the operation of termite mounds, as you can see in the image, which are complex structures that maintain a constant cool temperature, which is essential for growth of the fungus they feed themselves. The low temperature are ensured by a series of channels dug underground that create a ventilated environment. Engineer Cho Chen was inspired by the reaction mechanism of a pine cone in the rain to create a biomimetic facade. The architect realized that pine cones, in contact with raindrops, stretch their outer shell to protect their seeds, as you can see in the images. Chao Cheng say this natural phenomena led him to study the science of biomimicry and inspired him to design a laminate material that reacts with rainwater. By exploiting the material properties, Cheng was able to create a surface that changed its shape naturally depending on the humidity of the air, without using any mechanical system, as you can see in the image. The fiber expand in contact with water and open and close depending on the rain. So here you can see a clear connection between something that happens in nature and something that has been happening in architecture. The most efficient architecture are often inspired by animals or insects. Researchers and students at the University of Stuttgart used robots and drones to weave a carbon fiber pavilion inspired by silk hammocks spun by moth larvae. A 12-meter long cantilever structure known as the 2016-2017 ICDIPKE Research Pavilion that is made from over 180 kilometers of glass resins and carbon fiber. It is the latest in the annual series of pavilions built by students and researchers at the University of Stuttgart, investigating the capabilities of carbon fiber as a building material mimicking the natural world. The team of researchers studied the larvae of two species of moth, Lionella clericella and Leucoptera erintrella, that spin silk hammock extending from leaf to leaf to develop the key principle of a long span fibrous construction. Moth and their mode of construction were imitated, and the pavilion is characterized by multiple stages of fibers generating complex three-dimensional geometries. Researchers at the University of Stuttgart have also used robots to model a plywood pavilion laminated to the anatomy of the sea urchin, which is not shown in the images, but you can find it online. Composed of stitched plywood elements, it has segmented shell made up of hollow beech plywood components printed, laminated, and held together by industrial stitching. All processes carried out by a robot. The pavilion is intended to show the potential of computational design. The previous examples are just a few to show how mimetic dynamics, in particular those mimicking nature, have been and are fundamental in our architectural design process, an integral part of even the most advanced digital innovations. Biomimicry is particularly interesting because it is a technologically oriented approach focused on putting nature lessons into practice, a field where nature is seen as a model. The goal of biomimetic is solving human problems and contemporary challenges in a much more sustainable and efficient way, with the assumption that biological processes and systems do it best. Nature has been able to solve complex problems in a very environmental, ecological, and green way, and it is a very virtuous source of inspiration for design. Copying is a way of designing that starts from a reference model and replicates it, but this does not imply that the replica must be identical to the original model, because the replica can include a good degree of variation. This is the case of my mimetic architecture, where nature is a model, but the result is never perfectly alike to nature itself. Thank you very much.
Thank you, Dr. Pilar Maria Guerrieri, for your presentation. Now we shall take a short break for our sponsor video.
Regular cement takes 28 days to make an airstrip. This one just took 4. Yes, it is the technology of the future, brought to us today by Dalmia Cement. And I'm building my house with the same.
Dalmia Cement, future today.
I'm a forest ranger and I don't allow any interference in the jungles. But this wildlife corridor was needed, so we built it with the world's greenest cement, Dalmia. And now I'm building my own house with the same.
Dalmia Cement, future today.
An 8-foot slab of concrete that can take a load of 500 tons, moving at such speed. Yes, it's the technology of the future. Brought to us today by the pioneers of sleeper cement, Dalmia. And I'm building my house with the same.
Dalmia Cement, future today.